Okay, so over the past few months, the Gemma team has been on a roll. It's only about 6 months since they introduced Gemma 3, which was a whole suite of different models. But since then, we've seen the Gemma team actually go in two directions, which are really interesting. So the first one is that we've seen them go into making on-device versions of the models. So at I/O this year, Gemma 3N was announced around sort of June. It came out, and this model is pretty amazing with what you can do on device with this. And Google's put up a whole bunch of things around developer guides for how to use this, both on mobile phones, but people are also using these on Raspberry Pis and even in the browser. The other direction that we've seen the team go in is making models that can be used for various kinds of research. So one of the ones that I didn't cover, but I found very interesting was the whole T5 Gemma. So the T5 models go back to 2019, and they were some of the best transformer models that had both encoder and decoder. So the encoder obviously is similar to the BERT model, the decoder being similar to the GPT models. But it was really cool that the Gemma team released a variant of these that people could use for testing out a whole bunch of different research ideas, etc. Following that, the Gemma team released Gemma 3 270M. Now, this model is really fascinating because it's just so small. And yet they trained this on 6 trillion tokens. So we get to see actually what a small model can do when it's trained for a long time. Also, this model is ideal if you want to fine tune something that's really small for a phone or for something else at the edge. And that brings us to today, where the Gemma team is actually rolling out EmbeddingGemma. And the idea behind this is to have a really small model that can be used for doing embeddings on devices. So if you want to build like a micro RAG system for a phone, for a Raspberry Pi or something, then this is going to be the model that you can use for this kind of thing. So this is actually built from the T5 Gemma initialization, and they're releasing a variety of different versions that you can use for this. That are both quantized versions, I think some Onyx versions, some QAT versions, etc. And the idea here is that you can put in text, so they're not multimodal, they're actually just text only. But you can put in text up to sort of 2,000 tokens. And because they're actually Matryoshka embeddings, you can get different dimensions of sizes out. So that can be 768 at the biggest size, right down to 128 for the smallest size. So the idea with these is you've got some embeddings that are really small. They can be used for a whole bunch of different applications. And here we can see that they made a Hugging Face space to basically show off this, where you can just type in a mood or a scene, or in this case, as you can see, like I'm putting in a product, and then it will actually generate the colors that basically match this. So you can see this is what it's come out with in here. I said a sea storm. You can see, sure enough, we get different colors coming out of this. Okay, so the idea with these embeddings is that they're made for on-device usage. These are really tiny, right? We're just looking at 300M in here. So to put that in perspective, the Quen embeddings that I really liked recently were almost double the size in here. And we can see here, looking at their MTEB scores, just how EmbeddingGemma is actually comparing not only to that Quen model, which is no surprise that it's beating EmbeddingGemma, it's double the size. But even when we compare to other models that are similar size, or even some of the other models that are around double the size, we can see that EmbeddingGemma is performing really well for a whole bunch of these different tasks, whether that's retrieval, whether that's classification, or even things like clustering. So the cool thing with this is it allows you to basically do things like RAG, things like semantic search, etc., all on a mobile device without you having to have access to the internet. Let's jump in and have a little play with these in code so we can see what it can actually do. All right, so the way that you can use these embeddings if you want to use them in Python is to use the sentence transformers library. So this is similar to the transformers library. It's just made for embeddings. So you can see here that I can set it up to basically, I've got a query and I've got some documents, right? So in this case, my query is which planet is known as the red planet. I've got 4 different documents in there. And obviously our answer, we'd like the answer to be Mars coming out of this. But we can see that there's some other things in there that kind of hint at a red planet as well. So we've got 2 that mention this. So you can see that when we run this through, we basically encode our query. We then encode the actual documents. So this is the list of strings in here. If we look at those, we can see that sure enough, our query is going to be a vector of 768 in this case. And our documents, we've got 4 of them, and they're also vectors of 768. So now if we come down and we basically just do model.similarity, which is going to compare those vectors. So we've got the query embeddings, we've got the document embeddings, and it's going to print out the similarities. That's what we get back. So we can see that out of these, the second one is the highest similarity in here. And then what I basically do is I can just take the documents and do a numpy argmax on this vector that we got out here to get the position of the highest embedding and use that as the position of the string in documents that we want to print out. So we can see, sure enough, it comes back with Mars, known for its reddish appearance, is often referred to as the red planet. So that's just a simple example of doing straight up sort of comparison and stuff like that. Now you can also use this for making lots of embeddings for clustering, making embeddings for doing sort of classification, etc. Similar to this. Another thing if you want to try out is building different sort of little RAG systems and stuff. So I put together a very simple RAG in here that we're actually going to use just the Gemma models and just the sort of small ones. So in this case, I'm using the Gemma 3N model. You can play around with the Gemma 3 270. Both of these, I was having some issues just working out, okay, what's the string supposed to be going in? This seems to work better for me at the moment, so I've just gone for this one. But you could play around with this small one as well in here. Once you load that up, you just use that model. So obviously here, if I ask it, what is the meaning of life? We're going to get, this is the ultimate question. We get a sort of response out, right? Nothing unusual there. Then we want to set up the embeddings for this. So I'm going to use LangGraph and LangChain in here. I've done this from the base embeddings. One of the reasons is it seems that the Hugging Face embeddings seems to be for an old version of sentence transformers. There's some changes that seem to be for encode document and encode query, which seem to make this work. Whereas if I just use .encode, I seem to be running into issues there. From there, it's very simple. We can basically set up our Chroma database. We pass in those embeddings. This is where I'm going to save the database. I then basically bring in some data. So I've just brought in the blog post from the Gemma 3 270 in here. We're loading that up, splitting it up. Nothing fancy there, just really simple sort of chunk splitting. And then I'm actually splitting it out into texts. I add the text to the vector store. You can see that if I do some searches, it's looking like, okay, it's starting to find some of the right information. And then I basically just want to build a simple LangGraph for this. So we're just going to have, if we look at the sort of printout, we're just going to have a start, a retrieve section, where we'll go to the vector store, get the information using the EmbeddingGemma model in there, and then come back and generate out using the Gemma 3N model here. And you can see that here that we've got our retrieve node, which is basically just going to the vector store, getting the question that we've passed in, retrieving that. We've then got the generate where we're constructing a prompt to pass it in. I'm just passing it directly into this. So I'm not actually using the LangChain LLM kind of model system here. I'm just basically using the Hugging Face one, passing it in, getting it back, saving that in. And then we basically just add these together and compile it. So here you can see if we ask it basically, what is Gemma 270? Sure enough, it gives us a response back. Gemma 3 270 is a compact model for hyper-efficient AI. It then gives us some other information. If we come down and look at the response, we can see these are not great LLMs, and I probably should look into setting up the ML chat format for them to get better results out. But you can see that it certainly got what we wanted. So what is Gemma 270M? Based on the context, Gemma 270M is a compact model for hyper-efficient AI. It is part of the Gemma series of models designed for text generation, chatbots, code generation, creative writing, sentiment analysis. It gives us a whole bunch of list of things in there. It's suitable for on-device and research applications due to its size and performance. So it's certainly been able to do that, and it's used the embeddings in there to do this. Now, are these necessarily the best embeddings that you would use on a server, etc.? No. You can see here, though, just how much RAM that I'm actually using for those models. It's just tiny amounts of VRAM on the GPU in here. The embeddings themselves actually run quite quickly just off the CPU. So you can get some good results just running like this first bit up here. No problems just using the CPU in this. So clearly these are made for on-device use. And if you are looking at doing something like that, you can definitely set these up to run on a mobile phone and create embeddings for a whole bunch of different things. Earlier on, I showed you the mood palette one. If we come in and look at the code for that, we can actually see that really what this is doing is just doing an embedding of whatever you put in versus these descriptions, and then returning the name and the hex format back from this. So you can see there's lots of interesting things that you could use this on a phone, for games, for a variety of different things. And because it's so small, it pretty much will run on most phones that are out there today. It doesn't need to be the latest, most fancy phone. And when you combine this with the other Gemma 3 N series of models, etc., then you've got both the LLM and the embeddings to actually make some kind of RAG system or something. Okay, so if you're doing any work with mobile or on the edge sort of stuff, definitely check out these models. It is a really interesting direction how the Gemma series is splitting into sort of one path being on device stuff at the moment and one path being research focused kind of things. It will be interesting to see when we get a new sort of fuller version of Gemma, how they go with sizes and stuff like that. Anyway, as always, if you found the video useful, please click like and subscribe, and I will talk to you in the next video. Bye for now.